Okay, so for what we have here, again, we have the functions y is equal to 3x squared, y is equal to 0, and we have x is equal to 3. And this particular problem is going to be challenging, for we are now looking at the volume of the solid, which will be rotated not about the x-axis or the y-axis, but about the line y is equal to 27. And so for what we have in terms of the setup, from a graphical standpoint, okay, we have for the functions, okay, again we have with the quadratic function, okay, we have y is equal to 3x squared, and we have the vertical boundary x is equal to 3, and we have at the base y is equal to 0. And we are looking at, once again, taking the object and rotating about the line y is equal to 27. And now for what we are going to have in the ensuing development is that for looking at it in the context of establishing what the inside and the outside radius will be. Okay, so we will be utilizing the method of washers to determine just what this particular volume is going to be. And so just as a bit of a visual, okay, so we have 27, y equals 27 for the line. Again, we have with the function y is equal to 3x squared. And think of us having two halves mirroring. Crossing to the other side, excuse me. And so we have, in terms of the radius itself, okay, think of the outside radius. Okay, so we have for this triangular region, okay, we're going to have the radius to max out at 27. Okay, where we have connecting the base y is equal to 0 to y is equal to 27. Now, in the case where we had the radius to be anything but 27, okay, here we have a hollowing out, okay, for all the points from 0, 0 up to right before we get to the contact point 327. And for this open region, okay, this is going to be the inside radius. And for the inside radius, you have beneath the line y is equal to 27. Okay, the closest that this solid will get to y is equal to 27, okay, so we have y is equal to 3x squared. And so from start to finish, okay, the inside radius is going to be the difference between, or in essence, the height or the spread from y is equal to 27 down to y is equal to 3x squared. And so we have for the radius, okay, this will be at 27 minus 3x squared. And in looking at the solid that is going to be formed, again, utilizing the method of washers, okay, we have in this particular setup, okay, again, we have a washer. And so far as the features, once again, at the maximum, okay, we have the outside radius is going to be at 27, and where we have hollowing out space, say utilizing this washer, okay, that again is going to be at 27 minus 3x squared. And so with the method of washers, okay, we can determine the volume of the solid rotated about the line y is equal to 27. And so in the case of the volume, okay, we have again that v, okay, you have pi times the square of the outside radius minus pi times the square of the inside radius. Okay. And once again, in this figure, integrating over x. We're going from x is equal to 0 from the origin to the boundary with the upper limit x is equal to 3. And so utilizing the limits of integration, okay, as we go from 0 to 3, okay, it's going to follow that as we square the outside radius and the inside radius. Okay, we have 729 pi. We have minus pi and the square of 27 minus 3x squared. Okay, so we're going to have 729 minus 162 x squared, and we will have at the end plus 9x to the fourth. And once again we have dx. And so with the follow through, carrying out what we have at this juncture, okay, for the volume, again going from x equal to 0 to x equals 3, we're going to have the 729 pi's to cancel out, and so we are thus down to 162 pi x squared negative over negative is positive, and then we have minus 9 pi x to the fourth dx. And so in carrying out leftover with the power rule of integration, okay, it is going to follow that we have 54 pi x cubed minus 9 pi x to the fifth over 5 as x proceeds from 0 to 3. At 0, the expression is 0, but with the upper limit, which is going to ultimately determine the volume of the solid revolved about the line y is equal to 27, the exact value is going to arrive to 5,103 fifths pi.